Okay. All right. Chapter 6, Systems of Linear Inequalities. Okay. So systems is more than one, right? And so we're going to do some review skills from IAPR. So we start with lines and slopes. There's 4 types. Four types of slope. I'm just going to call it, remember we use the letter M for it. And some of you will recognize that slope is rise, right? The amount of vertical over the amount of horizontal, right? So rise over run. Does that ring a bell? Yeah. So that's basically, that's one way of thinking of a slope. But in general, we have when the slope is equal to a number over 0, okay, then we have what we call an undefined slope. Okay, and don't tell me that this is 0, okay? So think of any number. So let's say 2 divided by 0. If you want to try to divide anything by 0, you can't, right? It's undefined. So it's not 0, it's undefined. Very, very important distinction to make. So we have your undefined slope. So I'm going to make 4 columns here, by the way, side by side. So kind of try to keep this together. And then we have a positive slope. Slope. So if you have a ruler, it'd probably be a good idea to just split it up here. You have a negative slope. And you have the 0 slope. So positive slope is of course, if you get your slope and it's positive, then obviously we call it positive slope. If you divide the values and you get a negative, and then obviously slope is 0, which is anything like this. It could be 0 divided by any number. It is always 0. Okay. Okay, so for the undefined slope, we have, we're just going to do a little x and y axis here. Right, this is your y-axis, this is your x-axis. And I'm going to use a different color. I'm going to use red for the actual line just so you can see it. So let's say you have a vertical line. And by the way, if you have an undefined slope, that is what it looks like. It's a vertical line. And let's say this particular line goes through x is equal to -2. So the equation in this case would be x is equal to -2. So in general, it is going to be x is equal to a number. Okay? And it will be a vertical line. Then you have a positive slope, so let's just make an x and a y axis again. So I will just do this for all columns there. And so one thing we know about a positive slope is that it's going to increase from left to right. So just make a line that goes up like this, arrowheads on both ends. And do you remember your quadrants, right? This section here is called quadrant 1, and then it goes quadrant 2, quadrant 3, right? So one thing that you know is that a positive slope always goes from quadrant 3 to quadrant 1. No matter what happens, no matter where this line goes, if it's down here or up there, it's always going to end up in these two quadrants. So we can say that it rises from left to right. And in general, it's going to be y is equal to mx plus b. And this is a diagonal line. Some of you are like, yeah, I remember all of this as if it were yesterday. That's good. So then my negative slope, of course, is going to drop from left to right. The general form is always y is equal to mx plus b, so very much like the positive slope, and it's still a diagonal line. And last but not least, the zero slope, we have a horizontal, right? So we can make this positive here. Let's say you go through positive 3 there. In this case, the equation is actually not x, but it's y is equal to 3. So in general, the equation will always be y is equal to a number, and it will be the y-intercept. Should probably add to this part here, the negative slope, that it goes from quadrant 2, or one end is in quadrant 2, the other one is in quadrant 4. And this is a review of the slopes and how they relate to the line, right? And it tells you a whole bunch of, maybe I'll add this. This, we call that the Y-intercept, which is denoted by the letter B, right? Let's do that here as well. That's the Y-intercept, which is B. So the Y-intercept is given to us by the equation, actually, and vice versa. And here's a little, this is just maybe to help you out a bit. You can just discard it if you don't find this helpful. But Mr. Slope guy, right? Mr. Slope, have you heard of Mr. Slope? Okay. So if it's a positive line, right, it goes up. If it's a negative line, it goes down. A vertical line has an undefined slope, and a horizontal line has a zero slope. And there is your face. And students get creative with adding. Like I've had students make them look happy. So I don't know. Could be miss slope, right? There you go. Okay, so that's just to help you out if you need it. That. Yeah. So I'm gonna kind of just box this in a bit like that. There we go. Okay, now some writing. The equation, diagonal line, sorry, I should say is, sorry, comma, where M represents the slope and B represents the Y-intercept. To graph an equation comma start with the Y-intercept then use the slope and I will go rise and run to find additional points. Connect the points. Sorry. Add arrowheads. And label line with its equation. Please EQN is equation. If you want to get full marks, make sure the equation is right next to the line that you're graphing, okay? And this is just to prepare you for next year or next semester for some of you, right? Some of you are taking applied 4ES right away. Okay, all right. Okay, so we're gonna do some graphing here. I'm looking at my notes here, and this is not enough room. Let's try it. Graph the following. So we know that the slope is 2 over 1. And we'll say this, it's positive, right? So it will go up like this. And the y-intercept is -3. So 0, -3 is the y-intercept. Start here. So when you graph this, you always want to have a ruler with you, okay, for this unit, and like especially this unit, have a ruler with all the time. So we're going to start at -3 and we're going up, right? So if you want to graph this, you have to be really good at, so I'm going to, if this is my origin here, origin is where the x and the y meet, right? You're going to start at -3 and then go up from there. So I'm going to make my x-axis be here. So this is my x, this is the y. If you just spread them out equally, so this is what I mean, folks, you need to be equally spacing out your ticks, right? Or the spacing. As long as you're consistent, it's okay that the x and the y have different widths, as long as you're consistent, okay? So 0, -3 is right, so this is our x and a y, so 0, -3 is right here. 0, -3, right there. And so we're going to use our slope to get more points. And I always go from left to right, okay? So if this is where you start, our slope is saying that our rise is going to be 2 positive, so 1, 2, and our run is going to be 1. So you put a point down there. I will put some more marks here. So then it's another 1, 2 over 1. If you have 3 points, you have all you need to graph. So then this is what I don't want you to do. A lot of students, for whatever reason, they just do this and they leave it like that. That's a segment, that's not a line. So I want you to feel free to extend way past, because what you've just done is you found 3 points that lie on this line, but really there are infinite number of points on this line. And we're going to go y is equal to 2x minus 3. So by looking at the slope, I was expecting this line to go up from left to right, and I was going to start at -3 because that's my y-intercept. You need a starting point, and then you need a slope to go from there. You remember this stuff? Sort of? Some of you need need a couple of examples, that's fine. You had 3 different forms last year, at least. You had the general form, you had the slope intercept, and slope point, right? Point slope, same thing. We're basically going to stick with the slope intercept, and sometimes you're going to see the general form, and I'll show you how to work that. We'll make it work for us. Example B. Y is equal to -1/2 x minus 1. And C, we're going to do it right next here. Y is equal to 3. And D, x is equal to -2. Let's go -4. Okay. We will do these on the same graph, but this one we'll do on a separate grid. Okay. So just by looking at the slope, which is always in front of the x. By the way, you have to be careful. If this had been written like this, -1 minus 1/2 x, it's just flipping the terms. This is still my slope. It's whatever's in front of the x term, right? That is the slope. So don't let that fool you if I write it the other way. So rewrite it to make it look this way. My slope is -1/2. My y-intercept is -1, which I want you to think of as a point 0, -1. This is actually a point, and the y-intercept tells you that the x is equal to 0, right, at that point. So basically, this is going to tell us, because the slope is negative, I expect it to drop from left to right. Right? Slope is negative. That's what I'm expecting the line to look like. And so let's see. If you start at -1 and you're going to drop, right? You need to make sure that your negative has a lot of room. So I start with my y-axis. That's usually what I start with. And I'm going to start up here with my x-axis because I'm going down. So I'm basically zooming in. This is my -1 here. So I'm going to just make marks. 1, 2, 3, 4, 5, 6. That's good enough. So when you consider each one to have a unit of 1, then it's 1, 2, 3, 4, 5. I would just label every fifth. That's good enough for me. And then as long as you spread it out equally, so this is 2, 4, 5 right here. So now you're scaling it. It's all good. I start at -1 here. That's my starting point. And then I'm using my slope of -1, -1 over 2. Keep going. You're dropping 1 unit for every 2 that you're running to the right. Okay, so if you want to have this, I'm not going to expect you to do this, but you go 1 down, and then it's 1, 2 over. You're going 1 down, and then it's 1, 2 over, right? So that's basically what's happening there. And now that I have my 3 points, I line them up as best as I can, extend them, and put your arrowheads on, and you label it. That's it. So when you graph by hand, you have to think, where is my line going? Where am I starting? Where am I going? Right? Because otherwise you might run out of runway. You might not have enough room to fit that in. If you just make the classic, origin right in the middle of my page, it won't work. Okay. So this is B. We'll do C and D on the same graph. Okay. So in this case, this is a horizontal line. Line like this. Think of the horizon, right? And this is a vertical line. Okay. So I can go ahead and just make my classic X and Y axis. And I'm using my lines on this piece of paper. X and Y. And I'm going to go, don't have your units be too far apart, folks. You're going to run out of room. Make them small, but consistent. I don't want to see this. 10, 10, 10, right? That is not acceptable, right? So you're going to be consistent, and it's a bit of an art to get it, but after a while, you just have the feel for it, right? Like that. And so we're going to go 1, 2, 3, 4, 5. So I'm going to go -5 here. 1, 2, 3, 4, 5 going to the right. And I'll do the same thing here. 1, 2, 3, 4. That's all I get. 1, 2, 3, 4. And I'm consistent. I'm using my lines as a measure, so you got to be consistent. You can't do something else in the negatives and then change it when you go to the positives. Within the axes, it needs to be consistent. Okay, so that's good enough. We can go 4 here, -4, positive up there. Good enough. Okay, y is equal to 3. It's going to be 1, 2, 3. It's right here. This is where y is equal to 3, and we're always equal to 3. Y is always equal to 3, so that's why your line is actually a horizontal line, and that is y is equal to 3. That's the line y is equal to 3. X is equal to -4 is a vertical line, and it goes through -4. 1, 2, 3, 4, which is right here. So this is the line. X is equal to -4. Pop quiz. What are the coordinates of this point right here? This here. What's my x is -4, right? What's the y here? 3. There you go. See? Boom, you found the coordinates of that intersection, right? So we're going to do that pretty soon. We're going to have intersections happening. Okay. What about this one? I think I'm done with graphing now. I think you got it. So now we're going to rewrite and then graph. In some instances, you will need to determine the intercepts in order to graph a line. And I know that you should have learned how to do this last year. If not, here's your second go at it. Okay, so example, 3x plus 2y is equal to 6. The x-intercept is where the line crosses the x-axis. So what's y equal to at that point? If you cross the x-axis, what's y equal to? It's equal to 0, right? Oh yeah, I remember my teacher saying that. Right? X-intercept y is equal to 0. The y-intercept is the opposite, right? It's when the line crosses the y-axis, which means that x is going to be equal to 0 at that point. You're following me? Right? Okay, so what I normally do is I do them side by side. Bit of a T-chart there. So basically, to find the x-intercept, we take the original equation and we go 3x plus 2 times 0 because y is now effectively 0. That's what we're after, and that is equal to 6. So basically, this 2 times 0 just goes to 0, so it's 3x is equal to 6. We divide both sides by 3, and x is actually equal to 2, exactly equal to 2. So I want you to write it down as a coordinate. You've actually found that when y is equal to 0, x is equal to 2 is actually a point, right? This is the coordinate. Right? I want you to write it as a coordinate. On the other side, we're finding the y-intercept. So it's 3, 0, right? Because x is equal to 0 in this case, plus 2y is equal to 6. And this just happens to be an example where the numbers are nice and whole, right? There's no decimals, no fractions, but don't get too comfortable with that. Divide both sides by 2, and y is equal to 3. So what we just found is that when x is equal to 0, y is equal to 3. Okay? These are my my intercepts. Right? So you can have them side by side, and now you can graph it, right? So graph. I'll do that right next door to this. You're going to be so good at graphing by the time you're done this course that when you go and go into grade 12 applied, you'll be like graphing. I got this, right? I have no issues graphing. So 2, 0 and 0, 3, that's not a whole lot of points. So we can just go, right? Just make the marks like that, equally spaced out. And we're assuming that everything is worth 1 here. Okay? So 2, 0, we're not using the slope method here. We're using, right, 2, 0 is right here. And 0, 3 is right up there. 2, 0 and 0, 3. Okay? So is our slope positive or negative? It's negative. If we were to rewrite this, we would in fact get a negative slope. And in this case, you just label using this one. So can you graph this way? Yes. Find the intercepts. Can you graph the other way we just did? Yes. Start with the y-intercept, then use their slope. Hold on. Rewrite 3x plus 2y is equal to 6 into slope intercept. That's the only one we really need to remember, slope intercept. So, are you familiar with bringing stuff over the equal sign? Some of you learned it that way. Some of you learned subtracting or adding from both sides. It's the same thing, okay? So basically, I want this to look like this. Y is equal to mx plus b, right? That's what I'm after. So basically, your goal is to isolate y. So the next line here would be 2y. I'm going to leave 2y right here, is equal to the 3x comes over. It comes over subtracting. Remember that. Common mistake is to just have the 3x up here there. It's like, no, it's negative. And the 6 is positive. Okay? And then my next step is divide everything by 2. So it's y, that's what you want. So the 2 applies to that, so we kind of separate it like that. It will apply to the first term, and we write it like this. And it also applies to the second term, which goes like this. That's what you want. Could we have predicted that we would have had a negative slope? Yeah. Watch this. Is my y-intercept 3? Yes, it is, right? Could we have gone negative 3 over 2? Let's try that. 1, 2, 3, 1, 2. Bingo, you're on the line again, right? So everything is connected, right? Whether I'm talking this form or that form, we're talking about the exact same line, okay? So we need to be able to do all of that without issues. So now it's where you do a little bit of work and practice what we've just learned, okay? For each of the following, okay, I determine all intercepts rewrite into y is equal to mx plus b and graph. A 4x minus 2y is equal to 18. B, I'm just going to give you all of them. 6x minus 5y minus 25 is equal to 0. C, 3x plus 2y is equal to 12. 4x plus 7y is equal to negative 7. E 2x is equal to x plus 5. And y, just leave it easy, right? Can't do that. Okay. Give these a try. By the way, you can expect everything. You can expect horizontal, vertical, diagonal, everything. Okay, so when you do these, keep that in mind. Okay, so you get 4x minus 2 times 0. That's equal to 18. So this is really 4x is equal to 18. Divide both sides by 4. X is equal to 4.5. 4.50. Just follow for now, okay, guys? It distracts. So this is like this, 2y is equal to 18. Do not drop negatives, folks, right? So this ends up being negative 2y is equal to 18. In this particular case, you divide both sides by negative 2. Okay? So y is equal to 18 divided by negative 2, which is negative 9. So it's 0, negative 9. These are your two y-intercepts. Sorry, not just two. And then rewriting it, this is how you show this properly. Okay? The 4x comes over, so you end up with negative 2y, not just 2y, but negative 2y, negative 4x, and the 18 is already here on this side, so you just keep the sign there. And then you need to divide both sides by negative 2 because the coefficient in front of y is negative, right? So you end up with y positive, negative and negative turn positive, right? So you end up with a positive 2x because 4 divided by 2 is 2. And then it's 18 divided by negative 2, which is negative 9. This is how you rewrite it. Okay, so you have both intercepts and it being rewritten. Continue. Okay, B, I do the same thing. I'm doing them side by side, right? X-intercept, so we have, there's a little bit of a trick here. Watch this. I'm going to bring the 25 over like that. See what I did there? Because the 25 is negative. If I bring it over, you end up with 25 there. So don't let that throw you off. Does that make sense? Okay, so then x-intercept y is equal to 0. So watch, I'm just going to go ahead and just do this. I'm not going to show any more than I'm plugging in 0 because it's going to be gone, right? Divide both sides by 6. And you get x is equal to, and you can leave it as a fraction if you'd like. But if it's a decimal, we'll just round to 4.17, which is 4.170, right? And then on this side, I'll borrow this line again, 6x minus 5y is equal to 25. In this case, the 6x is going to be gone, so I'm going to end up with negative 5 is equal to 25. Divide both sides by negative 5. Y is equal to negative 5, right? 25 divided by negative 5 is that, so it's 0, negative 5. Okay? Rewriting it, I will start again with what I had. I will bring everything over except for the y, right? 6x turns negative. Negative 25 when it comes over turns positive. Divide everything by negative 5. Y is equal to negative and negative is positive, so I'll just leave it like that. 25 divided by negative is negative 5. So this is the rewritten form of that equation. Okay. C is 3x plus 2y, right? So the x-intercept, y-intercept. Okay, and that is 3x is equal to 12. Divide both sides by 3. X is equal to 4. So that ends up being 4, 0. Okay, and on the other side, I have 2y is equal to 12. divide both sides by 2, y is equal to 6, so that's 0, 6. Rewriting it, you get 3x plus 2y is equal to 12. So it's 2y is equal to 3x comes over negative. The 12 is already there. Divide everything by 2. Y is equal to negative 3 over 2x plus 6. I'm going fast, I know, but it's all on the video, so if you want to go back and check, you can do that. Is that making sense, guys? Okay, let's do the other one. I got to make sure I have the original in front of me because I forgot already. I gave you the one. Is that E or C? D? Sorry, it's D. So 4x plus 7y is equal to negative 7. The X-intercept and the Y-intercept are side by side. Okay, hold on. Before I continue, because the bell is going to go, I will finish this and then I'll give you some homework from this booklet I just gave you. X-intercept is 4x is equal to negative 7. Divide everything by 4. X is equal to negative 7 over 4. Negative 7 over 4, 0. And then here you have 7y is equal to negative 7. Y is equal to negative 1, 0, negative 1. Rewriting it, 7y is equal to negative 4x minus 7. Divide everything by 7. Y is equal to negative 4 over 7x minus 1. There it is rewritten. Okay. E. That was 2x. Watch this one. Look up to this one, okay? No y. This is a special case. Special case. It's a vertical line. Is there a y there? Right? No y variable. So 2x, guys, come on. 2x minus x, right? Because the x comes over subtracting is equal to 5. So x is just equal to 5. That's it. It's a vertical line going through 5, 0. And last one, negative half y minus 2 is equal to negative 5. Special case, no x variable. I will go 1/2 y is equal to negative 5 plus 2, because the 2 comes over. So it's 1/2 y is equal to negative 3. What do you do there to get rid of that half? Multiply both sides by 2, right? Because that will get rid of this. Y is equal to negative 6. So it's a horizontal line. Okay? All right. Homework. Page 3 in the booklet. Only do the odd ones. I will post the key later on. It's all about rewriting. It's rewriting into slope intercept form.